Hi guys, today we are going to learn about composite functions. Function composition is applying one function to the result of another. A composite function is created when one function is substituted in another function. The next slide I'll be showing you some example of composite functions. In this example, our fx is equals to 2x plus 3 and our gx is equals to x squared. X is just a placeholder. To avoid confusion, let's just call it input. So our F input, 2 input plus 3, and our G input, which is our X, will be input square, which is our X square. First we apply F, then apply G to get the result. What if we reverse the order of F and G? First we apply G, then we apply F to get the result. So we get a different result if we inverse the order. So the result will vary the same. So you could see the difference between if you multiply G with the fx and f with the input of gx. So be careful which functions comes first. In this example, your fx is 2x plus 3. So we are going to substitute the value of f into the fx. So compose with itself. When can even compose a function with itself. So 2x plus 3, you will be substituting the x placeholder with 2x plus 3. So you can see the detailed explanation working steps over there where you'll be replacing the x with 2x plus 3, and if you extend the 2x to 2x, which is 4x plus 9. In this example, our fx value is 3x plus 2 and gx value is x plus y. So I'll be showing you two different composite function where you will be multiplying fgx and gfx. If it's fgx, your gx is given, which is x plus 5, and you'll be substituting x plus 5 into your f function. You'll be replacing the 3x, which is the x input, with x plus 5. So later on you will be expanding that, so 3x plus 17. In order of that, if let's say you have gfx, you'll be replacing the gx with the x plus 5, the x with 3x plus 2. So you could see the detailed explanation, or you can see the detailed difference between if you substitute fgx and gfx. So as a conclusion, the value, the answer for fgx and gfx is not the same. In this example, our fx is set x and your gx is x squared. So the domain of your fx set x is all non-negative real numbers, and the domain of gx is x squared, it's all real numbers. We must get both domains right to compose the function and the first function used. When doing, make sure we get the function for fx to the right. Then also make sure that gx get the correct domain. Now x normally as the domain of all real numbers, but because it's a composed function, we might also consider as fx. So the domain is all non-negative real numbers. In this example, our hx is 3x minus 5 and your gx is 2x squared minus 7x. The question asking us to to calculate GHX. So you can rewrite the composition in a different form, which we used to write it in this form. So we are going to substitute the hx into the gx. So our hx is given, which is 3x minus 5. We are going to replace the each occurrence of x in gx with hx. So when we're replacing the x square input with 3x minus 5 square, you minus with 7, 3x minus 5. So you have to simplify the answer by first dealing with the exponent and squaring 3x minus 5. You'll be expanding the equation and then distributing and finally combining like terms. So we'll be collecting the x together and the numbers together. So at last our answer will be in the quadratic equation. Why both domains? Well, imagine the functions are machines. The first one melts a hole with a flame only for metal, and the second one drills a hole with a little bigger, works on wood, one metal. When we first see at the end of is a drilled hole, and we may think that we should work for the wood or metal. But if we input wood into the GF, then the first function F will make a fire and burn everything down. So what happens inside the machine is very important.